Here's a fairly simple example. We have 2a squared plus 3a plus 5 plus a squared minus 7. You want to combine your like terms. And so I'll write this as 2a squared plus 3a plus 5. The operation is addition. I want to line up like terms. So I'll put an a squared right here and this minus 7 where I have just a constant there on the end. Now as I add these, another common mistake for kids is they don't think about what they're doing. How many a squareds do you see? You see 2 here. How many are here? Hopefully you answer by saying, there's one of those there. And so if you have 2 plus 1, that would give you 3 a squareds. Notice for the middle term, there was nothing for it to combine with, so it's just going to come straight down as a plus 3a. And finally, we look at these constants. 5 and a negative 7 would be negative 2. As you look at these terms, an a squared is not the same as an a. You keep them separated. They must look identical. They must be identical in terms of variable expressions. And when you go to add them, you create no new animals. So that's why I could only add a squareds with a squareds. A was by itself, numbers with numbers. Final answer, 3a squared plus 3a minus 2. Know when to stop. You cannot combine those. I know it's tempting, but let it go. Let's do an example 4 where we have a subtraction. And let's say something like 5b squared minus 3b minus 7 minus 2b squared minus 4b plus 3. Again, you write the original set of parentheses. One of the things that I hate to see is when students are lazy. It only takes a second to rewrite this stuff. I mean, you could line them up with that, but rewrite it. Make it neat. The operator is subtraction. I bring the 2b squared. I line it up right there. Minus 4b plus 3. Now, with this operator being subtraction, I'm going to add opposites. So I'm going to turn this into an addition and then make everything change its sign. So this becomes a negative, a positive. You may have noticed that I didn't put a sign there because originally it was positive, and I knew I was going to change it to a negative, make it a little bit cleaner there. And now we do the subtraction. 5 take away 2 is 3, what? b squareds, because when we add and subtract, we create no new animal. Negative 3b plus 4b is just simply a plus 1b. You could write it like this, or you could put the 1 there. Doesn't matter. It's your choice. As we move to the constants, you owe me 7, you owe me 3, so you have 2 bills. As you add 2 bills, it's a bigger bill. You owe $10. There's your final answer, where we have the b squared, the b, and the negative 10. It is possible, I didn't show it in any of the examples, it's kind of an afterthought here, but it is possible, like if this was negative 3b and positive 4b, you can end up losing a term just because you had equal but opposite values. So it's not always a guarantee that if you start with 3 terms, you end with 3 terms, but most of the time it is that way. The only time there would be an exception is if you have equal but opposite values in any of these places. You could lose any of them. And is it possible for all of them to cancel out? Well, sure. You could have everything cancel out and end up with an answer of 0. That's possible.